So how do computers actually work? It's complicated. It's very complicated. Modern day systems are really fast. You've got your CPUs, your RAM, and then your regular storage, and they all work together to help process and store information quickly. But we've run into so many issues. CPUs have gotten so fast that RAM isn't able to keep up. We get bottlenecks there, and so now we've got innovations within the CPU where now you've got localized storage in there. Your caches, they help to store processed information. Then you've got your OS, which helps swap out information from the caches and RAM to figure out which is being used more and less, and there's algorithms for that. Now you've got AI that makes things even more complicated, and that's with billions of transistors that work together to make this happen. It's like, what are we even doing here? And so it got me thinking, where did it all begin? It all started with this. Okay, let me break this down real quick. Okay, transistors are really cool. They're basically like gates. They allow current to either flow or not flow. If we're able to control current, then we're able to control output. So what that means is, if our output is an LED, and we can control the current, we can control whether or not that LED turns on or off. So let's hook up the system and let's see what it looks like. So, Vs is our voltage source. If I connect my button to the voltage source and then connect it to this transistor in the middle pin, that's crucial. Now, on my voltage source, I'm also going to connect my transistor here. But remember, no current's going to flow until this middle pin gets input or gets a current. This is connected here to our LED, which is connected to ground. Right now, no current is flowing, okay? The moment I press this button here, current flows here, down here, across into the transistor. Now this middle gate here acts like kind of like the switch. So if it receives current, then it allows current to flow from here to here. So we then see current moving through here, up into the transistor, down through the transistor, and into the LED, turning the LED on. So by pressing the button, we are able to generate an output, which is that LED stays on only when we press the button. Okay, so here is the circuit essentially laid out, where we have current going through one of the buttons connected to the middle pin of the transistor. So that acts as our gate. As soon as I press this button, current will flow from this blue wire through the transistor into the blue LED and back to ground, completing the circuit, which will turn on the LED. So let's see what happens. Type shit. So essentially, by pressing this button, we are able to control current to do what we want to do. This is massive, okay? This is the breakthrough that can let us build some really crazy shit. You might be thinking, what kind of crazy shit can we make? But I'm gonna make a calculator.
What? Bro, what are you talking about, man?
So, I opened up my computer and began planning. Everybody starts somewhere. Anyway, after a while, I got this. So, what the fuck is this? It looks kind of weird, but let me walk you through it. Essentially, my calculator is going to have two sets of inputs, and the inputs are going to be in binary. Essentially, you'll have a 2 to the 0 bit and a 2 to the 1 bit, and you'll have two of them that you can add with each other. So the A dash represents 2 to the 0, which is 1. The B dash represents 2 to the 1, which is 2. The total combinations you can have here, because there are 4 buttons, is 8. Now the outputs work in a very similar way, where this LED represents the 2 to the 0 bit, which is number 1, and then 2 to the 1, which is number 2, and 2 to the 2, which is number 4. So in theory, if I put into my calculator an input of 1 and 1, then only this second LED should turn on, because 1 plus 1 is 2. 1 plus 1 is 2. Now, if I wanted to do 3 plus 3, which means both the buttons on both sides of the input, then these two LEDs should turn on, because 3 plus 3 is 6, and here we have 2 to the 2, which is the number 4, and here we have 2 to the 1, which is the number 2. If you add them together, you get 6. If I turn all of these on, you can see here, both these LEDs turn on. Great, so we've done a couple of tests and they work for those ones, but I went ahead and I wrote the test cases for them anyway, so I don't have to do this all by hand. Ooh, that would have been super zoomed in. Oh well, let's have a look. Have a look at that. All the tests are passing. We're going to move on. Second phase, which is online schematics. You can see me in the back. Seriously, the holy drag. This was about 2 weeks worth of work and it still doesn't work. Let me show you what's going on. Before, in that simulation, I was using logic gates, ANDs, ORs, XORs, because we can use transistors to model those kind of gates. So what I tried to do before I wanted to build the system, model it online first to see if it'll work. It did not work. I still don't know why. Essentially, I have one power rail here, ground, and everything's kind of connected off it, and everything's supposed to be linked up. Right now, I have the number 2 on, but the number 2 LED is not on. So there was some weird things going on here. So 2 plus 2 is 4, which turns on. So that's going on now. Let's turn all of these on, and these two work. But the issue that I was having before was that with the number 2 on, the number 2 LED did not turn on. I don't know why. I have no idea why. And I spent weeks on this, right? And then I had to go overseas for a trip, so then I stopped. Now, once I came back, I'm not gonna lie, I could not be asked to continue this project. I mean, the schematics weren't working, and obviously I was gonna base my design of the system from the schematics. But I went back to basics, and this one YouTube video saved this entire project. This video right here from Global Science Network. This guy put me on so hard.
What?
He's going over 2 different XORs. He also shows you how to wire them up, and then he also shows a simple schematic for it. So this right here saved the project 100%. You guys gotta check this guy out. Now that I had kind of like a fresh start, I pulled out some breadboards and I just started putting transistors on there. And after all that, we were left with this. This is what we are left with, and it's sick. Firstly, there's a battery pack on the back, taking on the coin batteries. Completely portable. If you ever want to know what 2 plus 2 is, now you can with my calculator. Let me show you how it works. Well, you already know how it works, but let me show you how it works in the real one. So there's an on switch here, and how do we know it's on? We have an LED indicator for power. Feature-rich design. Apple, if you want to hit me up. NASA. So this works exactly the same as the models that we ran before. If you come back here and we want to do 1 plus 1. Now that's this button and this button. That would be 1 plus 1. So if I turn these two on, then only this LED should turn on. So let's see if I can do that here. So 1 plus 1. You can see that there, only that second LED turns on. We can do 2 plus 1, right? So we can do 2 plus 1. And what that will do is that'll turn both this LED and this LED on. 2 plus 1. 3. Now what if we press all the buttons? Then only the 2 left LEDs should turn on. 6. 3 plus 3 is 6. How cool is that? That the entire circuitry, every operation that's happening is right in front of you. I don't know about you guys, but I looked at this and I saw art. So I spent $8 whole on a photo frame. So the last step of this project here is to strap it in and hang it on my wall somewhere.